Welcome to the PCS Electronics Test Bench. Today on the bench we're going to be looking at the Magnum Energy ME2012 2000 watt inverter. Okay, let's start by taking a tour around the inverter itself. The Magnum comes in two different types for this size inverter for the 2000 watt. Well, a couple of different types, but the most common are this one, which is the step wave unit, and then they have a white case that is a sine wave unit, be the MS2012. The gray case like this one happens to be the ME2012, so it's a 2000 watt step wave output inverter. These inverters are commonly found in motorhomes and boats. Let's take a look at the connections first. Of course, we have the battery terminals, negative, positive, a ground connection for chassis ground, your AC input ports, input-output ports for your AC wiring. Right at the top here, you have a little push button for turning the inverter on and off manually from this location. It's also done remotely. You have a green LED that will blink the different modes that it's in. Usually blinks a slow blink to show that it's inverting or charging the batteries. Okay, this top port, the red one, is used for an external device, typically one they call the DC disconnect. If you see a cable in here, then what that does is that cable will be tied to a 12 volt source, and whenever that 12 volt source goes to zero, the inverter will shut off. So it's used to automatically shut the inverter off for storage or for any other reason, or even for just be used as a remote on-off. The green port, if you see a cable in here, it's most likely going to be going to a automatic generator starting system. So this is like a network communication port, and it will plug into another control box that is capable of starting and stopping your generator based on if your battery is getting low, and other features as well. The blue port is your remote control panel. So most places will have, most RVs you find this in will have a cable in here for its remote panel for switching the unit on and off and seeing whether it's inverting or charging and so on. So that's your remote panel. The yellow is the bottom port here. That's your battery temperature sensor. So there'll be a temperature sensor in the battery compartment and plugged into here so that the unit can alter its charging based on the temperature of the batteries. Over on the side of the unit, we have your AC wiring. So this is just an access port. Wires will come in over here and then into the top of the terminal strip. You secure the wires here with the screws. You'll have a circuit breaker here on all the units, and then you could potentially have two more circuit breakers here, which would be a different model. Would be the ME2012-20B, which will have extra circuit breakers for the output. There are a couple different ways you can wire this unit. You have a ground terminal here, again for chassis ground, and then you have your inputs, your input neutral, and input 1, input 2, and then your output neutral and your output 2, output 1. Often you'll see the two inputs tied together, so you'll actually have a jumper in here like this tying the two inputs together. So if you only have a single AC wire coming in, sometimes you'll do this to give you input to both circuits through the inverter, and then you'll get AC coming out both outputs. If you don't need to have that, they often do that just to help increase the current capacity by having the two circuits going through the unit instead of just the one. If you're only going to use one, you have to use input 1, otherwise the battery charger won't work. I have seen them with jumpers in the input and jumpers in the output to jump them both together. If you only have a single cable in, single coming out, and you've got a heavy load on those single set of wires, I have seen them jump both the inputs together and the outputs together like that. So you have one big single circuit going through it. But most of the time you'll have, just one going in, one going out, or you'll have one going in and you'll jump this together and you'll have two circuits going out to different parts of the motorhome. Okay, so let's discuss the main functions of the Magnum ME2012. This is a step-wave inverter, 2000 watt, 12 volt input. 12 volt inputs right here. Your connections here are a remote panel connection. Here's one of the remote panels. And then there is a battery temperature sensor connection. And on these sensors, this gets bolted to, normally gets bolted to a battery terminal. So it bolted to a battery terminal, and it's just for the purpose of picking up the temperature of that battery. This tab is not conductive to any of these wires. It should not be, or you're going to have a problem. It's simply to transfer the temperature to the sensor inside this case, and then the microprocessor in the inverter reads that temperature, and it will alter the charge cycle so that in the summertime you prevent overheating the batteries, and then in the wintertime it'll charge them a little harder to get them fully charged if they're cold. So the bottom one is the battery temperature sensor. Then you have a remote. You have two more ports here, and you can use these for accessories that are available. One accessory is the automatic generator start. Magnum sells a module that plugs in here and will start your generator automatically if your batteries get low. So these are accessory ports. And then of course you have your AC input area here and the terminal where it connects. Okay, so let's take a tour of the inside of a Magnum ME2012. The main board here in the bottom is your what we call the FET board, or your power board. This is where the battery voltage actually gets inverted. You have a control board, which is the board with the microprocessor on it that controls all the functions of the inverter and also communicates with external devices via the connectors on the end of the unit here. The power gets switched, DC battery voltage coming into the inverter gets switched back and forth into the primary of the transformer, the output of the transformer, two wires going into what we call the AC board. The AC board has feedback sense transformers for voltage and current, and it has a ground bond relay and a power transfer relay. There is also some filtering. You have a cable coming from the AC board back to the control board, so the control board can operate the relays and read the sense transformers. So that's the inside. Oh, you have the terminal strip with 3 inputs, 3 outputs. Okay, so you have a neutral and an L1, L2, and then a neutral L1, L2. The inputs can be configured a couple different ways. This one that I have right now, you have your neutral and you have the 2 phases L1, L2 just jump together. And if you have a 30 amp service, this is how you'd connect it. It just goes straight through as 2 120 volt circuits. Comes out as 220 volt circuits in reference to your neutral. You can also feed 240 volts to this input. You'd have your neutral, your L1, L2, but you would actually have 240 volts here. You wouldn't have this jumper. You would have 240 volts across that point, and that's perfectly acceptable in these, and it will simply come out 240 on the other end. with neutral. So then you have 120 to neutral, 120 to neutral, 240 between two hots, and that's an acceptable way to wire these units as well. The current coming into these units can get quite high, so we have very large wires on our test bench. I forget what the continuous rating on this one is, but you got to be able to support a couple hundred amps coming in, and it actually will pump a couple hundred amps, 200-300 amps into the primary of this transformer. You can see how heavy these wires are because there's a lot of current. And then your output, since it's up at 120 volts, you have thinner wires, lower current. The ground bond relay, what that does is whenever the code is that you're supposed to bond the neutral to ground at the source of power. So when the inverter's running, this is the source of power, and this relay will actually drop out and connect your ground to your neutral, so it's bonded at this point. When you have AC coming in, this relay will open up, releasing that bond, and then your bond is back at your power panel or generator, wherever the power is coming from. So that's your AC bond relay. This relay passes the power through, so when you have AC coming into the unit, this relay closes and just passes the power straight through to the outputs. At that point, the unit becomes a charger, and the AC actually, this was once your AC output, now becomes your AC input, and then that goes into your inverter, literally backwards into your inverter. The inverter does some switching that boosts that voltage and charges your battery, so it's an inverter charger. So all these boards are available from Magnum, so this thing can be repaired. It's one of the nice things about Magnum inverters. They have a good warranty as well, so very reliable units. You know, a lot of these units are in RVs. So on the Magnum ME2012, you have this small button on the side that you can use to control the on-off. So I can turn the inverter on from here and turn it off. And then if you have the remote plugged in, then you can control it from the remote. So let's quickly go through the different modes. Right now, we are in invert mode, and there's my output waveform, 123 volts. I don't have a lot of load on it right now. In fact, I've got almost nothing, so we've got no current. I'm going to go ahead and put about 1,000 watts of load on here. Okay. And now with 1,000 watts of load, I've got about 7.28 amps going out, AC. We have 122 volts. And we have 84 amps coming out of our batteries. So that's in the invert mode. On the remote, it's telling us we have 11.5 volts, 96 amps. Now if I bring in shore power, turn on my shore power, there'll be a blinking light on the display saying it sees the AC. And after some delay, you'll hear it click, and it will pass the AC through. So now we have a sine wave coming through. It's being passed through from the shore power. The inverter has shut off, and now the charger is going to be ramping up. So if we look over here, we'll see the current on the charger coming up. So that's current being put into the batteries to charge them, and the voltage at the batteries will start to climb. And then we're just passing our utility out. In this case, I have 117 volts AC passing through the unit. So under this condition, with charging, I have 15.5 amps coming from shore power to run the battery charger, and the load that I have switched on, which is 1,000 watts. Fans have just kicked on because it's going to get warm doing this. See, I still have 7 amps out, which is my 1,000 watt load. But the battery charger also running, I've got 15.3 amps coming in. Some of that's my output load. So if I went ahead and shut my load off, okay, so now we're dropped down to 11.3. We have almost no load on our output. So all of that current coming in now from shore power is for the batteries, to charge the batteries. And it's currently charging at 75 amps. So over on the remote, it tells us that we're bulk charging 14.3 volts, 85 amps. So that's the charge mode. Now, if the shore power were to be removed, we'll show you what happens here. So we have the utility power, shore power coming straight through. We're looking at the output of the inverter. If I turn the shore power off, instantly the inverter takes over with the step wave, and now would be powering the load. And the battery charger will shut off at that point. So that tells you on the remote that it's inverting. So that's your charging and your inverting mode. So now I want to run through the settings on the remote that you really need to know about. I'm not going to go through everything. I'll do a separate video on all the settings on this remote. And of course there's the user's manual as well that you can refer to. But what I'm going to try and do here is just show you the absolute minimum things you need to check to make sure everything is set right. Most of it, the factory default is just fine, and there is a button on the side, the same button that turns the unit on and off that I showed you earlier in the video, that if you hold it down for 10 seconds it will reset all the settings back to factory default. So if you're not sure where you are or you want a good beginning point, just do that factory reset. So let's get started with just the remote here. This is the MERC50 remote. There are other versions of this, but this is the most common one, and most likely the one that you would have with this Magnum inverter, the ME2012. First one, we'll just start with the buttons going for a while. These buttons, you know, these are the inverter on, inverter off. The inverter button itself, you push it and it starts inverting. The charge button, normally it won't turn the charger on because unless I have shore power coming in, that won't come on. And when you do have shore power coming in, as you saw with what we did earlier, as soon as you put shore power in, it goes into the charge mode. So really the only button, this button normally is just for turning the charger off once it's started, if you want to do that, because normally it will just start up as soon as shore power comes in. The inverter button can be used to turn the unit on and off anytime, and if you are on shore power and it's in pass-through, then you want to make sure this light is on so that the inverter is in standby, so that way as soon as the shore power goes out, it'll jump over to inverter. So that's just your inverter button on off, charger button on off. First button here is shore power. Factory default is 30. Just leave it there, it's fine. You don't really even have to know what that does, and you won't have any problems with it. You don't have to change that to 50 if you plug into a 50 amp outlet. Just leave it at 30 and it's fine. That's the factory default. The AGS, this is only if you have an automatic generator start system plugged into this unit, and that's all the settings for that. We're not going to go through that. We'll do that in a separate generator video. The meter is just when you want to read things, the normal voltage and current. And there are if you press the meter a second time and you rotate this, there are other settings for another option, a battery monitor option. I'm not going to cover that here, but that's what that second push is. So normally you want to just see that you've got your voltage and your current, and it shows you whether the inverter is inverting or charging or whatever. So that's your normal setting. And if you're in any other menu and you just want to get back to the meter, you just push meter.
the setup. This is the many different settings in here. I'm just going to show you the ones that you probably should check. Search watts is the first one that comes up. You push the button, tells me it's off. If it's, I would just leave it off, unless you absolutely have to try and minimize the load on your batteries. Just leave it off. Otherwise, as discussed earlier, you can cause problems with things not turning on. If you did want to change it, you just rotate this, press the button. Now it's set for 10 watts. If I go back in there, see the arrow's on 10 watts. It's wherever the arrow is. So see if I go to 15 watts, there's no arrow. No arrow at 20. So it's wherever you see the arrow, that's where it's set. I'm going to bring it back here to off. Push the button, arrow's on off, so that's turned off. After search watts, you have low battery cutout. The factory default for that is fine, which is 10 volts. If you want the batteries to shut down sooner, you can do that. That's just how low will you let the batteries go before the inverter shuts off automatically. And 10 volts is the factory setting, and that's fine for a 12 volt system. Let's go back in the setup, search watts, low battery cutout, absorb time. You do want to check this one based on the size of your battery pack. If you have the typical 4 battery pack, 4 6-volt batteries, then the factory default, which is 1.5 hours, is fine. This is the amount of time that you want the batteries to be in what they call absorbed during the charge cycle, which is where it will simply hold a voltage for a certain amount of time on the batteries to make sure that the entire battery pack gets charged, and then the charger will shut down. So again, if you wanted to change this time, you just rotate the knob. So if you have 6 batteries in your battery pack, you may want to bring this up another half an hour. But the 1.5 is fine for your typical 4 battery pack in an RB. Next one is battery type. This one you definitely have to make sure this is set correctly. Flooded is your typical lead acid battery. You have other AGM settings. And again, if you wanted to change it, push it, see the arrow changes. Back in, let's go back down to flooded. Gel types. There's different types of batteries. So if your typical lead acid battery, you want to set it to flooded. Okay. Next setting would be, what do we got next here? Charge rate. This one I'm going to discuss because 80% is the factory default, and normally that's okay. But just so you know, as we saw with the test we did with the shore power, the shore power can, you can use up a lot of your shore power current charging your batteries. If you're the type of person who pulls your RV into a spot in the morning, plugs it in, and it's plugged in all day long, there's really no reason to ram 100 amps into your batteries and try and get them charged up as fast as you possibly can. It's hard on the batteries. It uses up all your shore power. So you don't really need to do that, and you could turn this down to say 50 or 60%, and that would lower the amount of current that the battery charger will draw off the shore power. It will take longer to charge the batteries, but if you're going to be parked there all day, who cares? You've got power from the shore power outlet. You don't really need the battery power anymore, so it's charging. You got all day to let it charge, so lower the rate. So you could just leave it at that lower rate, forever, and just the only time I would change is if you pull in somewhere and you really got to get those batteries charged up in a hurry for some reason, then you can change this. You can go all the way up to 100%. In which case it'll put in over 100 amps into the batteries. So the factory default's 80. If you're not in a hurry to charge your batteries, I wouldn't put it higher than 60. Just let them take their time charging. It'll keep the unit running cooler. It'll be easier on the batteries. It'll still get charged. So the next setting Volts drop out. This is normally 80 volts, and that's fine. That just means if your line voltage coming from a shore power drops below 80 volts, then the charger will stop. It'll shut down. So that's the point at which it shuts down. 80 volts is fine, so you don't have to mess with that. If you frequently have power that runs lower than that, I don't know. Maybe I can't imagine you'd want to go lower. You can, but 80 volts is about as low as you probably want to go. And for some reason you want it to cut out sooner, you know, you can set it up to maybe 100 or so, 95, and all that would do is if you do get a power sag, it would go ahead and shut off the battery charger. Okay. Next would be, but at the same time, it's also, I believe if you do that, it's also going to stop passing the power through. So I guess you could look at this as maybe a way to save your equipment that's plugged into this from a brownout. So if you had some high-end stereo equipment plugged into this thing, you didn't want it to see a low voltage, you could set this up to whatever, you know, 100 volts or so, and what it would do is if the line voltage gets below that point, then it just disconnects everything. Your stereo and everything's just going to go dead, but you're protecting it from a low voltage situation. In some cases that can be damaging. Factory default is 80 and is typically fine for any kind of equipment. Setup, search watts, see better. What else do we got here? So those are the ones you really need to know about. Power save features, just how these LEDs and screens react. Don't have to mess with that. Screen setup. Final charge. This factory default's multi. That just means it's going to go back and forth between float voltage and charge to keep the batteries correctly charged. You can set it to float and it'll just stay in float. I think at that point it has to go down below a set voltage. I'd have to look into that, but I don't know that one off the top of my head. But the reality is you don't have to mess with it. Just leave it on multi, and that just takes care of itself. Again, in this video I'm just going to try and get you the minimum of what you need to bother with. Power up always. Yeah, just leave that alone. Again, we'll have another video where we go into these things in full detail. But so really, well, the last one. Let's do the last one first. Tech is the last button. You can get temperatures. It'll tell you what your battery temperature sensor is reading. It'll tell you what the big transformer in here is reading, and what they call the FETs, which are field effect transistors, and those are the transistors on your inverter board in here. So you can actually check to see how warm the inverter is. It's, you know, make sure it's not getting too hot under any conditions. Trying to think. I think the battery. I only know off the top of my head. I only know the temperatures in degrees C. The not the battery. The battery will be whatever the temperature outside is, wherever the batteries are. Transformer, I believe, can go up to 140 something C before it'll shut off. FETs, I believe, will go up to like 80 degrees C before the unit will shut off, and it'll give you a high temperature setting. If you ever need to know, let's back out of here. Tech. Okay, that was the temperatures and tech and the revisions. This just tells you the firmware revision of the controller firmware in the unit. If you're ever talking to tech support and they want to know what your firmware revision is, it tells you it's 5.9 there. It tells me my remote firmware is 2.7. There are other accessory readings in here you can do, but we don't have those accessories. So that's all the buttons. So really, let's go back over this one more time, just see, for people who really don't like to mess with all these buttons. I'm going to tell you real quick the only things you should probably check. Shore power, just leave it where it is, 30 amps. Don't bother with it. If you don't have a computer, if you don't have a generator hooked into this thing, then you don't have to worry about that one. Meters, just press the button so you can see the readings. Otherwise, that's it. Setup's the only one where you got something to do here. Make sure your search watch is off, then you don't have to worry about it. You want to make sure low battery cutout is, the default's fine, don't bother with it. Absorb time, that you just got to make sure, depending on how many batteries you have, that's long enough to get a full charge. Again, 1.5 is fine for your typical 4 battery pack. Battery type, again, this one is an important one. Got to make sure that's set right, flooded, AGM, or whatever type you have. Charge rate, that's an important one too. If you have problems blowing your shore power breaker out there a lot, you may want to turn that one down if you don't need to charge those batteries so fast. That's about it. I mean, you really don't need to know anything else about this just to operate this unit. Okay, so there you have it, the Magnum Energy ME2012 step-wave inverter. If you want any more information on Magnum Energy products, you need to know that Sensata Technologies merged with Magnum, and Sensata brought with them Dimensions inverters. So if you go to the Magnum Energy website, which is now I think the Dimensions-Magnum.com or something like that, it'll say Sensata Technologies on one side of the screen and Magnum Energy on the other, and Dimensions. So they're all now one. Or you can contact us, and they have tech support at Magnum Energy. You can call them directly. It's often hard to get through. They're very busy, so you'd be on hold for a while, although they do have a callback function. So if you ever had problems with this unit or had questions, you can call tech support directly at Magnum. Here at PCS Electronics, we also take calls if you're interested in having us repair your unit, or if the unit goes down and you're not sure what to do, you can call us. We'll help you through it. Okay, so that wraps up this bench video. I hope it was helpful. Thanks for watching, and see you on the next video.